Hello, and welcome to Anyscale Connect. Today we have Ameer Haj Ali, who is a project manager at Anyscale. As you'll see, we're really lucky to have him here, not just because he finished his PhD in 2 years, but because among his other leadership roles, Ameer leads the Ray Autoscaler team, and today he'll give us a glimpse into the Ray Autoscaler. With that, here's Ameer Haj Ali.
Okay, hello everybody. My name is Ameer. I'm a project lead at Anyscale, where I lead the Autoscaler efforts. And today I will be giving you a glimpse into the Ray Autoscaler. And I will start with some very small description of what Autoscaler is doing. So basically, Autoscaler is a background process that runs on the head node of every Ray cluster and monitors the user's application demands to then automatically scale the cluster to the minimum size that fulfills these demands. This is basically a TLDR of what Autoscaler does. And Autoscaler is basically started by the cluster launcher. So the cluster launcher launches Autoscaler. So today, what basically happens when you're calling Ray up in the CLI or create or update cluster from the SDK is on your laptop, there are calls to the cloud provider, or for example, AWS, that tells it to give your laptop a node, and Ray makes it the head node. And on that head node, we basically upload the file mounts and run the setup and initialization commands of the head node. And then we start Ray and the background process of Autoscaler that runs on the head node. And then Autoscaler manages the life cycle of the workers by, again, doing the same process for the head node, but of course, without starting Autoscaler. So it launches these workers and upload the files and setups the workers and starts Ray. So let's take a deeper look on this worker lifecycle managed by Autoscaler. So Autoscaler launches, of course, based on demand. It launches workers based on how the user interacts with the application or how the application is demanding resources. It terminates nodes when they are idle or when they fail to start or set up or initialize, basically in the launching process, or when the node becomes outdated. And by outdated, I mean if you change the node config in the cluster YAML to, for example, instead of M5 X large, it becomes M4 or some GPU instance, these nodes become outdated and they are removed. And finally, Autoscaler is responsible for restarting workers when, for example, Raylit crashes, or when the user changes the setup or start commands in the YAML file, or the file mounts change. Let's take a deeper look at how you configure Autoscaler. Basically, the configuration of Autoscaler is mainly through the cluster YAML, which I assume some of you are familiar with. I want to go briefly over what are all these fields doing. So basically, the cluster name is a unique identifier for the cluster. This is basically an ID for your cluster. So somebody else who has the same name and is using the same cloud credentials or the same account that you both share will be able to access this cluster if they give the same cluster name. And then we have the max workers, which is a global maximum limit on the total number of workers that Autoscaler will ever run at a given time. So the server size will, or the cluster size will never be larger than max workers, the global constraint. Then we have upscaling speed, which we added recently. The upscaling speed basically tells Autoscaler how aggressively to add new nodes. So the larger this value, you will be adding more and more nodes much faster. And it basically puts a limit on the total number of pending nodes. So if you first have a very few nodes that are running, you will add nodes gradually until the cluster becomes larger and larger, and the speed at which you're adding will increase after you have more and more active nodes. Then we have the Docker configurations where you specify the image, the container name, and if you want to pull the latest version or whether you have some extra options that you want to provide. Of course, we have also custom, you can also provide a custom Docker image for the workers or the head node separately, but I have not showed it in this particular slide. And then you have the cloud provider fields, where, for example, here I provided an example in AWS with where you have to provide type, region, availability zone, and you can also provide cache stop nodes, which is activated by default. What cache stop nodes does is when you terminate a node, it doesn't actually terminate, it goes to a stopped state. So in the next time you scale up, you reuse the stop nodes and therefore you start faster, and it's activated by default. And then we have the available node types, which was recently introduced. So for some of you who were using older versions of Ray, you probably had only one type for the workers and one type for the head node. And we recently added available node types where you can specify multiple node types. Like you can set M4 X large, you can set P2 X large, you can provide as many as you want. And here, you have to provide the node type and then the node config, which previously was in the head node and worker fields. Now they are under node config. For example, here we provided the instance type. You can also specify the storage size, etc. We have the resources, basically how much resources this instance has. If you're running on AWS, we have logic that automatically detects these resources, and therefore you just have to provide the instance type without the resources. You can specify min workers and max workers per node type, or you can specify even initialization commands or worker setup commands per node type. This way, you can customize every type of workers and to have custom commands, custom configurations, and you can also add custom resources like you see here for your cluster. And also it can detect GPUs of special types automatically for AWS. And then you have, of course, to specify the head node type. So when we start the head node, we can know which from these node types to make the head node. The authentication with which Ray will authenticate every newly launched node. And then idle timeout in minutes, which is basically the time that Autoscaler takes to terminate an idle node. So basically, if the idle node was idle for X minutes or idle timeout minutes, this is when Autoscaler will terminate it. The file mounts, which is basically a mechanism for you to upload files from your laptop to the head node or the worker nodes. So basically what happens here is that we upload the files to the head node and then from the head node to all the workers. And every time these file mounts are changed, these files get updated. And the way the API here is basically you put the key as the remote location and the value as the local machine on the local path on your machine. We have the initialization commands, which are a list of commands that run before the setup commands. And if Docker is enabled, they run basically outside the container before the Docker is set up. We have the setup commands, which are a list of shell commands that you can run or to set up the head and workers. And sorry, if Docker is enabled, these commands run in the Docker container. You can also provide a custom setup commands to the head or the workers separately by providing head setup commands and worker setup commands. Ideally, if you're installing packages or cloning repos in the setup commands, you should consider having a Docker image with these pre-installed packages or the clone repo. It might make yours launching a bit faster. And then we have the head and worker start commands, which you generally do not need to modify. These commands are basically running Ray start on the head and workers. And in the general use case, you don't really need to modify them. So once you have configured your Autoscaler and started your Autoscaler, when does Autoscaler actually upscale? There are 4 things that basically Autoscaler looks at before making the upscaling decision. It looks first, of course, at the main workers, at the resource demands, basically the application demands, the placement groups, and the Autoscaler SDK request resources API. I will go into detail on all of these in the next slides. From this list of inputs, Autoscaler calculates through binpacking which node types to start and how many. So let's go deeper into when this is happening for every one of these cases. So for min workers, we get the Autoscaler gets the min workers basically from the cluster config, where you set their min workers for every node type. And then the second one is the resource demands. For example, here we have a remote function f with 2 CPUs each, and we're calling remote on 3 times for this function. This translates to resource demands CPU 2, 3 times here. If you were familiar with the previous versions of Ray, we did not have this support where we actually calculate exactly how much the application takes, and based on that, we can exactly figure out how much really the number of nodes or which node types you need. It was mainly based on the utilization of the current cluster, and based on that, we would add nodes without actually knowing how much it should be. But with this new Autoscaler version, we have the ability to know exactly how much resources your application needs through this simple resource demands collection. Then we have placement groups, which was also recently introduced inside Autoscaler, where it basically allows users to atomically reserve groups of resources across multiple nodes. Basically, what you can do, before running your application, you can define a placement group. Let's say you want 1,000 CPUs, and this will request 1,000 CPUs that will be always available for you to run things on. And you can run applications inside this placement group. And I will give an example in the next slide. This can be helpful, for example, for Gantt scheduling, where you want all the tasks or actors to be scheduled and start at the same time. Or if you want to maximize data locality, for example, you don't want to do a lot of data transfer. You already know that these kind of actors or tasks will share some data. Or you can do some load balancing by telling Autoscaler to place these actors or tasks on physically different machines. Let's take an example of placement groups. So what we have here is, we have import Ray, and then we are initting Ray to connect to the default address, basically to the cluster we're running on. Then what we're having here is we're defining 2 bundles, bundle 1 and bundle 2. First one is 2 GPUs. Bundle 2 is basically extra resource 2. And we're defining a placement group with these 2 bundles. And we're telling Ray to prepare this placement group and wait until it's ready, or basically when these resources are available. What we did here is use strict pack. Which means that if these 2 bundles fit into one node, they will place inside one node. And it tries to strictly or maximize the packing into collocating basically these bundles on the same node. There are other options like strict spread, which will try to place these bundles on completely different nodes as much as possible. There is pack and spread, which are basically based on best effort. And then finally, we schedule F in this placement group by calling f.options remote, and this will run F inside this placement group. And this placement group will live as long as your application is running, and you can always run things in this placement group. And finally, we have the newly introduced SDK request resources. It basically commands Autoscaler to scale the cluster up to the desired size. So basically, the cluster size will never be smaller than what you provided in the request resources. Let's say you wanted 100 or 1,000 CPUs. your cluster will always be at least the size that can fit 1,000 CPUs. So it does not matter how much utilized the cluster is. It just puts a minimum quota on the resources that your cluster size should be. So for example, if you request resources with num CPU is 1000, this will allow you to do, for example, f.remote 1000 times without any autoscaling. If you have not run anything before that, because this should accommodate 1000 function calls of one CPU. Of course, if you are running already many nodes, this will not add much more nodes to what you're currently having. So for example, if you have min workers very high that can fit this 1000 CPUs, request resources might be redundant. Then we have another example here with bundles, 1 GPU and CPU4 and 64 CPUs. And then finally, you have another example where we're providing the same bundle 3 times, or basically CPU1, which is equivalent to request resources with num CPUs 3. So with these 4 concepts, we feed as an input to Autoscaler. And the autoscaling algorithm is very simple. It's run in 3 steps. First, we add the nodes to satisfy min workers and request resources, if necessary. And then after we calculate how much nodes we need to add for min workers and request resources, we bin pack the placement groups and resource demands on the available node resources and calculate the remainder. In the previous versions of Autoscaler, there was no bin packing and we could not calculate the exact resource demands, and we used only to look at the utilization and based on that to guesstimate basically how much workers to add without actually looking properly. But with the new one, we can know exactly how much resources you need. And for every bundle in the remainder, we add a node that can fit the bundle with the maximum utilization. So we take a node and we add the bundle to it. Generally, we pick the one that would maximize the utilization. So for example, we would try, if we took an empty node and added one bundle to it, we will try to continue adding to it until it's no longer possible to add to it. And then we go to the next one. And even when we pick it, we pick the smallest possible that can fit this bundle. So how the bin packing actually works, let's take an example. Let's assume here that we have a list of resources requested by the application. We have 6, for example, 6 CPUs, then 5, et cetera. And let's say that we have only one type of workers that can fit 9 CPUs. The bin packing will basically try to bin pack these as much as possible inside these resources. And then it will launch nodes based on this number of resources. Now, keep in mind that the upscaling speed can slightly change how much nodes are added simultaneously. So if you have a very high upscaling speed, these nodes can become available immediately. But if you have maybe a small value, we will first add, let's say 5, and then we will add 10, and then we'll add 20 gradually. Now, many of you might say or observe some issues with Autoscaler, or maybe want to know what Autoscaler is doing, how many nodes are running. And for that, we have the Autoscaler logs. Basically, Autoscaler updates the logs every 5 seconds. And these logs are very helpful for you. And actually, if you look after you call Ray up, we have a lot of usable commands for you that should be useful for you to look at these logs. For example, here, to monitor the autoscaling, you just have to call Ray exec cluster YAML with this command. You can run this command directly on the cluster when you are actually connected to the cluster. And we have recently, within the new nightlies that we have now, introduced additional logs on top of the logs we previously had. So previously, we would show, the cluster would show what is launching. It was not very well organized. It will also show how many resource demands are there. but now we have added on top of these logs that we added on top of it other Autoscaler logs that shows you a summary basically of how many pending nodes are there, how many are healthy, if there were any recent failures, how much utilization is there, and if there are any demands. And the next thing you can look on is basically the Ray dashboard. You can call Ray dashboard cluster YAML and access it on this link. Here's an example of how the dashboard looks like. You can see, for example, the host, the uptime, the CPU utilization, how much RAM, and disk. And there are many other things that you can see in the dashboard that I have not shown here. But basically, you can use the dashboard to view the cluster metrics, the errors, exceptions, and you can also detect some anomalies, or you can even kill actors directly from the dashboard. And this is basically it. And to wrap it up, Autoscaler manages the lifecycle of Ray workers. It scales the cluster to the minimum size that fulfills the user demands, and it provides the user a serverless experience. This basically describes to you in a high level what Autoscaler is doing. And next, I want to show you a quick demo. So here I have a terminal. I want to first attach to my cluster. I have already started a cluster here. I want to start IPython. I want to import Ray, import time. Import time. And then I want to define a function, a remote function, ray.remote, def time.sleep. Let's just make it sleep for 5 seconds. And then I want to call Ray init, address equals auto. There we go. And then let us call ray.remote on this function 150 times. Ray.get f.remote for in range 150. So the next thing I'm going to do is I want to run the command that I showed you to look at the logs. We have here the command. I'm going to re-exec that, and let's see what we can see here. So as you can see what Autoscaler is running on the workers it's starting. You can see the commands that are running there, the setting of tags, a bunch of setup information. And here goes the summary that I showed you. Basically, you have the node status, we have how many are healthy, how many are pending. As you can see, we only have 10 here. Probably if the upscaling speed was higher, we would have started more aggressively, and then you will be seeing more pending nodes here. There's the recent failures, etc., etc. We can also, another thing that we can look into is the dashboard. And for that, I'm going to run Ray dashboard. Once it finishes, I can go here, go to localhost and 8265. It printed to me the port, and that's why I already know that it's here. It was printed here. Okay, let's see. So here you can see my cluster. It has now 14 hosts, 28 workers, 56 cores. Let's see what else. You can also see the CPU every worker is using and how long it has been running, how much resources, memory it's using, how many data sent or received or logs or some errors. Okay, so at the very end, you can also see that at some point we also reached 19 hosts. Previously it was 14. So we're adding more and more nodes. Once the application finishes, Autoscaler will wait the idle timeout, and then all these nodes will be removed. Okay, so now our cluster, after all the tasks have finished, is back to 2 CPUs on demand. That started with, because I set the min workers to 1, and we have 1 head node and 1 worker. And also, as you can see, the dashboard has only these 2 workers. And this basically concludes my talk.
Thank you so much, Ameer Haj Ali, for your talk on a glimpse into the Ray Autoscaler. So with that, we'll take questions. The first one is, how is the autoscaler different from the autoscale of Kubernetes?
Yeah, that's a good question. So in our own Autoscaler, because you're running Ray functions, we know exactly how much resources, or let's say number of CPUs and GPUs your functions are using, and therefore we can know exactly how many nodes to launch. The one in Kubernetes is similar in the sense that it adds nodes when you have a very high utilization, or you're having a pending pod or something like that, and downscales the cluster when there are some idle pods. But in our case, we know much more than within Kubernetes. Kubernetes is just based on very high-level utilization that is not as precise as in our case. So ideally, our autoscaler should be better.
So the next question is, are we maximizing data locally and load balancing built-in strategies in placement groups? Or is this something we have to write ourselves?
So it is built in the placement groups. You just have to specify if you want to use strict pack or strict spread to decide whether you want to maximize locality or load balancing respectively.
Oh, thank you. So the next question is also about placement groups. And it's, if I set a placement group with 2 GPUs and 2 CPUs, in cases where the GPU node also has enough CPUs, how will the placement group be configured by Ray? On GPU only nodes or GPU plus CPU only nodes? Seems both can satisfy the bundle request.
Yeah, that's a good question. So if this is one bundle that has 2 GPUs and 2 CPUs, we will find the smallest node that can fit both. If this is 2 separate bundles, ideally we would put them on one node if they fit. But if, for example, the first one was the CPU, and then you had another bundle that was a GPU, we might actually first start the smallest node that does not have GPUs, and then only the other smallest node that can fit the GPUs. But ideally, if it's just one bundle, which I understand is the question indicating to, it should be the smallest node that can fit the 2 GPUs and 2 CPUs.
Oh, okay. So the next question is, what is the difference between minimum workers and request resources? Is request resources more specific to instance types like CPU or GPU?
Yeah, so min workers is something you define in the cluster YAML, and this is something that will only be changed or modified once. This is something that you set exactly in the cluster YAML, and when you call way up, you can somehow no longer modify it. For request resources, you can from within the code request that, and you can dynamically change that to increase the size of the cluster or reduce its size. And yeah, it's also more type specific, so you can specify CPUs and GPUs and request resources, but min workers is just workers. It does not allow you to modify exactly or precisely pick the resources you need.
Oh, okay. So someone said, thanks for the talk, very interesting. So the question was, can we also specify RAM and disk as part of bundles besides the CPU or GPUs?
Unfortunately not. So you cannot really specify RAM or disk in your bundle. You can only specify CPUs, GPUs, or any of the custom resources that you add in resources in the build. Like you can add maybe a TPU or some custom resource.
Okay, so the next series of questions are all about Kubernetes. So the first question is, how does a Ray Autoscaler interact, influence, or relate to the Kubernetes Autoscaler?
Yeah, that's a good question. So our Ray Autoscaler does not interact with the Kubernetes Autoscaler. This is like two independent entities. Our own Autoscaler is managing the cluster of Ray. Even if you're using Kubernetes, it will add more pods or reduce pods. It does not interact at all with the Kubernetes Autoscaler. We don't use it in our own Autoscaler. But if you want to use Ray with the Kubernetes Autoscaler, we recently added the Kubernetes operator, and you can actually run the Kubernetes Autoscaler with Ray. So we have two options for you. You can either use the built-in Kubernetes Autoscaler, or you can use our own Autoscaler. And our own Autoscaler will not interact with the Kubernetes Autoscaler.
Okay, so the next question is the dashboard available in Kubernetes with or without a Kubernetes Autoscaler? Or
Yeah,
sorry, without a Kubernetes operator?
yeah. So the dashboard is available in Kubernetes and all the other cloud providers. It is not related to where you're using it. Yeah, so it is available.
Okay. So the next question is, I was interested in using Ray Autoscaler with Kubernetes, as I like to scale worker pods with requested resources. Is this possible?
Yes, you can use Ray Autoscaler with Kubernetes with the request resources API.
Okay. And a couple more questions. So in the new format of the logs that show recent failures, would it be possible to identify the reason for failure, i.e. spot node shutdown versus memory overflow on the node?
So within the logs in the monitor logs, you generally have the reason for why the worker failed. But also now you're gonna have it also in your terminal when some nodes fail, and you'll have a summary of that. I don't know specifically if the memory overflow is something that we can always catch, but generally in the logs, most of the reasons for why the worker failed is available in monitor.logs.
Okay, so the next question is about EC2 fleets. So what's the best way to emulate EC2 fleets where you can list a range of instance types, particularly for Spot, so that there's a good chance of getting a suitable Spot instance when required? So with ASGs, you can launch templates for this. Can we use those, or is there an equivalent in Autoscale?
Yeah, so currently you cannot really emulate the EC2 fleets. You will have to change the code of Ray of Autoscaler to accommodate that. I can't really think of a way for you to emulate that in EC2 fleets.
Okay. So the next question is there a possible way to put different initialization commands to different node bundle types? And they clarified, here I mean the resource composition for a specific node that you showed before, specified in the YAML.
Yes, there is a way to specify different initialization commands for different nodes. So inside your available node types build in the cluster config, you can, for every node type, specify different initialization commands. And you can also specify different setup commands, but you cannot really do that for every bundle. This is like per node. You can't really change initialization commands per bundle.
Okay. So another question is there a possible way to put different initialization commands? Oh, already read that, sorry. The next question is, when specifying GPU resources, is there a way to specify the memory requirement rather than the utilization fraction?
Um, so I'm not sure I understand. So you no longer need the utilization fraction. When specifying GPU resources, you cannot specify the memory requirement, and in the newer version of Autoscaler, you don't need to specify utilization fraction because we can already calculate how much resources you need, and based on that, launch only the necessary number of workers needed for that. So you no longer need to specify utilization fraction. Instead of that, you can specify upscaling speed, which is the question of the previous person here who asked, like, if you know. Yeah.
So that previous person asks if you know exactly how many resources are needed. So why don't you need to scale up at a certain rate, or why do you need to scale up at a certain rate? Why can't you just scale up to the exact number needed?
Yeah, that's a good question. So we know exactly how much you would need, but we set up the upscaling speed. And by the way, you can set it to a very high value, and then we will launch immediately. But if your tasks are very short tasks, and they theoretically seem to require many more nodes, but if they finish very quickly, the startup time of the worker might be longer than the time this task is taking, and therefore it might actually still be beneficial to start gradually launch workers, because by the time you will launch even the more and more workers, you will not really be using them. And another thing, even if you start them simultaneously and run these tasks, you don't want every worker to run for just 1 second and then wait for the idle timeout for it to be shut down. So this is somewhat being more cost aware and more careful about how much you really need. So if these tasks are really taking a lot, we will exponentially add more and more nodes. So it shouldn't be of a big concern. But if you already from the scratch know that your tasks will take a long time, you can increase the upscaling speed. You can use placement groups that also bypasses the upscaling speed. You can use request resources that also bypasses the upscaling speed. And you can also set the main workers.
Oh, thank you. So the final question I'll take is, will the recording be shared? And this recording will be shared on our Anyscale YouTube channel. I'd also like to thank Ameer Haj Ali for taking the time to not only give a talk, but also answer questions. Thank you so much. If you have any further questions, you can contact us at events@anyscale.com. Thanks again, Ameer.
Yeah, thank you very much for hosting me. Thank you. Have a good day.
You're welcome. Have a good one.